Self-contained systems is an architectural approach that separates the functionality of a system into many independent systems. Each self-contained system is an autonomous web application and is owned by one team. Communication with other self-contained systems or third-party systems is asynchronous where possible. There are other features of a self-contained system, and we get into them in this episode. As Eberhard Wolff explains, self-contained systems is not the same thing as microservices, but they are not mutually exclusive. Organizations often adopt a mix of architectural ideas, and it is worth understanding these different models so you can decide for yourself which of them to apply to your own projects. Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. Eberhard Wolff works at InnoQ. Eberhard, welcome to Software Engineering Daily.
Yeah, thanks for having me.
Today we're going to discuss self-contained systems, which is an architectural pattern you are advocating for. What is a self-contained system?
Yeah, so the idea is that in a way self-contained systems are just microservices, so they can be deployed independently. However, we try to make it more specific. So self-contained systems are web applications. So they do have a web UI. They would render HTML and do these kinds of things. And there's actually a website where you can look up all the information about self-contained systems. So compared to microservices, they're actually pretty well defined. So you can look it up, see what the definition says, and then you can see whether something is a self-contained system, while it's not so clear with microservices. The definition goes on, and it says that self-contained systems should contain the UI, the logic, and also data access. So persistence logic is also part of a self-contained system. So it's all in one system. Also, it has its own database schema. So it would store its information in a separate schema from other self-contained systems and other systems. So you can actually change them as you wish. And obviously they are somehow connected. So they are modules of a larger system. And the way they integrate, we prefer to do integration on the UI layer. So HTML links or other kinds of web integration. Then we advocate asynchronous communication. And lastly, we also allow for synchronous communication. So that's basically what it is. The idea is to build a system out of web applications and then integrate them on the UI layer or through primarily asynchronous communication. That's sort of the idea.
I like the idea of self-contained systems being like microservices, except well-defined. Microservices is one of these things where it's like you struggle to... I've done a bajillion shows about microservices, and people struggle to agree on a definition for it. So I did an interview with Jonas Bonner recently, and we talked about what it actually means, especially in contrast to service-oriented architecture. You and I are both hosts on Software Engineering Radio, and we've done some shows on that distinction as well. But what Jonas talks about in terms of microservices versus service-oriented architecture is that microservices are basically the modern manifestation of what service-oriented architecture was. So we had this movement towards cloud, and mobile, and perhaps things like the Reactive Manifesto, where we've come to conclusions about the ways that we want to build our systems, and the principles that service-oriented architecture was advocating, like isolation, I don't know, there's other traits. These are things that are also true about microservices, but microservices are merely the modern manifestation of those principles. And it sounds like the idea with self-contained systems is to take those ideas from microservices and then put even more prescriptions around the ways that we should build these systems and the services within those systems.
Yeah, in a way that's true. So let me first of all elaborate on microservices versus SOA, because I actually believe that those are two separate things, and not necessarily by the way that they are implemented, but rather by the goals. So I would argue that SOA is something that you do on the enterprise level, where you basically want to change the way your enterprise works, your whole IT infrastructure works. So you would build, you would have all the systems, and they would provide services, and ultimately all of your IT systems would provide such services, and you would integrate them. And I would argue that microservices in general are aiming at something different. So I would argue that it's a decision that you make in every project. So either you want to do your project using some traditional modularization technique, like, you would come up with, modules inside your source code or something, or you could do it using microservices. So the scope, in my opinion, is just a project. But on the other hand, you're right. I mean, even looking at the name, microservices say that you would provide a service. So in a way, it's related to microservices. And I would believe that this is something where self-contained systems put a different emphasis on things. So the idea with self-contained systems is to look at the graphical user interface and to provide everything, to provide the UI, the logic, and the persistence. While in some SOA approaches, of course, there are a lot of different SOA approaches, but in some SOA approaches, the idea is to separate the UI and to have a portal as a generic UI to all of your services. And this is something where I would argue self-contained systems are more about vertical split, while some SOA implementations advocate a horizontal split across, to separate it across, to have a UI layer, to have an orchestration layer, and then to have the sort of atomic services. So I think in a way, self-contained systems are quite different to at least that understanding of SOA.
Are self-contained systems like an emergent property of some successful architectures that you've seen, or was this like a deliberate decision that some people made to move towards this SCS model?
I think the key is that it is something that we see working in quite a lot of projects. And it's not just me, it's also not just InnoQ. If you look at the SCS homepage, it's actually a lot of companies that do these kinds of things. So one famous example, at least in Germany, is Otto, which is the global number 3 in e-commerce. And they have a large project that they themselves claim is done using the SCS approach. So in a way, I would second what you said, that it's something that a lot of people see working in a lot of projects. It seems to be something, if you look at the success stories, that has a lot of traction, at least in Germany. And that was one of the reasons why I really wanted to do this podcast, to spread the word and to also make people in other countries aware of what is going on here in Germany and how some people are attacking these challenges that we have and what this approach to microservices is like. So it's not something that I just do or that just InnoQ does. It is something that is much broader. And if you look at the website, you will see a lot of links to different people talking about self-contained systems and doing it themselves.
There's this important emphasis in the self-contained systems architecture where each self-contained system is an autonomous web application. Why is this important?
It's important because if you look at, your average feature request, I would argue that it will touch the UI. And to contain such a feature request in just one system, you would need to include the UI in that system. So not just logic, not just persistence, but also the UI. And that is why we put that emphasis on web applications. This is also something that a lot of people are, let's say, confused about, because they say, well, so I'm building this API and, I don't have a web UI. So why can't I do self-contained systems? And you can't. I mean, you literally can't because you don't have a web UI. So there is no way that you can do self-contained systems. But still you can do this vertical split. So, to have one functionality like a checkout in an e-commerce system or a user registration or something like that, like a functionality, and put that in one vertical system. However, in the case where you really just provide an API, it would just be an API and that's it. And you wouldn't call it a self-contained system. Still, you can still use some of the ideas of self-contained systems. Also, self-contained systems allow you to do an API in addition to a web UI. So if you have a web UI and also you want to talk to mobile apps, for example, you can definitely do that. You will provide an API in addition to your web UI in one self-contained system, but still it's mandatory to have a web UI. And also I think one of the reasons why it's included is to be more specific, to say, okay, this is a self-contained system, and if you don't have a web UI, it's not called a self-contained system, and it's a very specific definition for that reason. At the same time, what you're doing can still make perfect sense because, there are obviously architectures that do make sense and are not self-contained systems.
In a company, you don't need to have all of the systems as self-contained systems in order to have some of them as self-contained systems. Is that accurate?
Right. Yes,
so
right.
You can have kind of a heterogeneous architecture where you've got some self-contained systems and maybe those interact with other self-contained systems or with other microservices.
Yeah, or just traditional backend systems and so on. And that is also one of the things where I'm actually not entirely happy with the definition, to be perfectly honest, because what the definition says is you must include the logic in the self-contained system. However, I have a hard time imagining that in any and every case, you can just have all the logic in your self-contained system. So I wouldn't be surprised if you still call to some backend, and I think that's still fine. It's not like you must have all the logic in your front-end system. That will not make any sense. But still, you should have as much logic in there, and you should also have the persistence in there to contain a feature request, as I said, in one system. Still, it might make sense to have a backend system and to have your self-contained system talk to a backend system.
We should be talking more about this interaction pattern. The entire company is made up of these different self-contained systems and perhaps microservices, perhaps other back-end systems, like you said. What are the ways that these self-contained systems and other services, how are they interacting with each other?
Yeah, so that is one of the things that I think is the strength about self-contained systems. So it's actually pretty clearly defined. So what it says is that you should aim for asynchronous communication. And the reason why you want to aim for asynchronous communication is because then you don't need to care about, failure cascades, for example. I mean, one of the problems that you have with these kinds of distributed systems is that, well, if one system fails, it's bad if that leads to an error cascade and makes all the other systems fail. And ultimately, it's just a small piece of the system that fails, but nothing works anymore because all the other systems are also affected. If you do asynchronous communication and the system fails, well, it just adds to the latency, and you have to deal with latency anyway. So it's not that much of an issue. So for that reason, we advocate asynchronous communication. Now, if you do, and there is some confusion about asynchronous communication. So what does it actually mean? So the sort of definition of asynchronous communication that we're talking about is, imagine that a self-contained system receives an HTTP request, and it has to answer that HTTP request. What it must not do is talk to another system and wait for the answer. So that is basically what this kind of asynchronous communication is all about. So now you might wonder, how do you deal with a case where you definitely want to get some information, some data from some backend system to fulfill the request? And well, if you want to do it asynchronously, you need to replicate data. That's basically what it boils down to. So you need to talk to the backend system, and you need to do an asynchronous call, and it will provide you all the updates of the data, and you would store it in your own database. And then you have asynchronous communication. So you would replicate the data, store it in your database. And then if a request comes in, you just do it or handle it using the data that you have in your database. So that's the idea. However, as I said before, I mean, obviously that means, you have to replicate data, and there's the cap theorem. So it's your choice to either be consistent or available. And there are these issues around consistency. So if it is also still an option to do synchronous communication, but then you have to deal with the error cascades. So that is why we focus on asynchronous communication.
When I'm choosing the tools for my side projects, the first thing that I look for is ease of use. That's why I love MongoDB. It is the most popular non-relational database, and it is super easy to use. At the beginning of a project, I often don't know the shape of my objects, and Mongo makes it easy to evolve the database schema as I like over time. Over time, as my project gets popular, I'm going to need to scale, and thankfully, MongoDB has built-in horizontal scalability, but configuration and database maintenance aren't really what I want to spend my time on. Thankfully, MongoDB Atlas was released in 2016. MongoDB Atlas is the easiest way to get access to MongoDB without having to run the database yourself. You pay only for what you use, from small projects all the way up to large production deployments. To try MongoDB Atlas today, go to mongodb.com/sedaily and get a free $25 in credit. Use promo code GOATLAS25 to get that $25 in free credit. Atlas is the only hosted MongoDB service built by the engineers behind the database, the company MongoDB. With Atlas, you get end-to-end encryption, you get VPC peering, you get access to the latest releases, and for a limited time, you can go to mongodb.com/sedaily, enter promo code GOATLAS25, and get that $25 in credit and get started with MongoDB Atlas. Thanks to MongoDB for being a new sponsor of Software Engineering Daily, and thanks for being the database behind a lot of my favorite side projects in the past. We're really happy to have MongoDB as a new sponsor of Software Engineering Daily. The asynchronous versus synchronous communication discussion is pretty important. So as you said, I want to drive this point home because I think some people are not familiar with asynchronous versus synchronous communication. With asynchronous communication, you can make a request to an external system or a service, and you can just continue with your own thread, and eventually you get a callback that is asynchronous with your own thread. And this is in contrast to the idea that if you make a request and then you block until you get a response, that can lead to a severe failure if there is a large delay in getting that response. And in the interview that I did with Jonas Bonner recently about reactive microservices, he also talked about the asynchronous communication being really important. It's one of the properties that are explored in the Reactive Manifesto. Is the idea of self-contained systems architecture, is that also influenced by the Reactive Manifesto?
Of course, this is something that is important and interesting. However, I think we actually do have a somewhat different idea about asynchronous communication. If you look at the non-blocking I/O things and these what is usually something that you would call reactive, this is not necessarily what we are talking about. So it would be perfectly fine to have, an HTTP request and to have a thread that is blocking and would get some data from somewhere and put it in your own local database. That's perfectly fine. It just must not happen while you are receiving a request. So it would be possible to use your traditional servlet-based model where you would have a thread and the thread is blocked because of I/O. And you would have one thread that says, okay, I'm just copying over some data from some other system and do that. And you have another thread that handles an incoming HTTP request. The only thing is that you must not wait for any other system to react, and that's it. And I think you can basically implement that using, reactive systems as well as your traditional blocking I/O systems. So it's both possible, and that is why why I keep talking about this definition of asynchronous communication, because it's asynchronous communication on a different level. I would argue it's not necessarily the level that the reactive guys talk about.
Well, then let's go deeper into that. So by emphasizing asynchronous communication, you encourage the system to adopt eventual consistency at more levels. Explain that in more detail. Why is this useful?
Well, because it boils down to the question, how do you handle, the problems that you have in distributed systems, that nodes might fail and that you might have a node failing, and you don't want to have all of the system fail. So the way to deal with that is to not talk to that node and not do synchronous communication, but rather copy over the data beforehand, and then you're just using your own system, your own database, and you basically are not really even developing a distributed system, because if a request comes in, it's just handled in your own system with your own database, and that's it. The downside of that is that, you replicate data, so you would have your own copy of the data that might or might not be consistent with what other people have. So, for that reason, you might come into situations where data is inconsistent, and that's sort of the downside of the whole thing. Let me add one thing, because I think that's really, really important. And I think one missing link that is often forgotten about is the discussion around domain-driven design and bounded context. So what we are saying, or what you see in microservices, is that people say, well, a microservice should be a bounded context. So let's assume that we have a system, an e-commerce system, and you have a product search. And there is another part of the system that handles the orders and your order history. Both of these systems have some kind of products, and they have some model for a product. I would argue, if you look at the catalog, that product would contain, the size of the product, the color, the current price, all of these kinds of things, because you really want to have the customer search for the product and ultimately find the product. If you look at the order history, the only thing that you're really interested in is the historic price of the product. So the price that you paid for it when you ordered the product, because it's part of the order history. So these are two bounded contexts. So if you look at one bounded context, it's the search and there's all the up-to-date information and it's pretty detailed because you really want to have people find the product. And on the other hand, there is this model for the orders, for the order history, where you're only really interested in, well, the historic price. Now, if you apply that to these questions around inconsistency, well, those two systems don't even share data because they have they are different bounded contexts. So it's not useful to even talk about inconsistency between those two systems because they have very different models of the same kind of data, so the product in our case. So I think one of the things that is often forgotten in this discussion is, yes, almost any system in your e-commerce system will talk about products. So it seems as if there might be inconsistency around the product, but really it's different facets, different bounded contexts, different models for the product. So the question whether you really have inconsistencies is a completely different one because it's really different data that you have. And for that reason, I think in some cases, if you have a really smart domain architecture, the problem around inconsistent data might not even, surface because it's really different data that all of those systems have, even though at first sight it seems as if they have the same data because they all talk about products, for example.
With microservices architecture, you often have these services that are dependent on each other, so you can get these request chains, and if you want to have a graceful failover, in the event that one of those dependencies in the chain goes down, you need to implement a circuit breaker pattern. Does the self-contained systems model have this property of dependencies as well, or is there something about self-contained systems that lets you avoid that type of request chain problem?
I would argue that the ideal self-contained system would handle the request based on its local state and its local data and would not call any other system synchronously. And in that case, you don't need to have a circuit breaker because you don't talk to other systems while you handle a request. And I think that's actually one of the strengths about that model. So if you come up with self-contained systems, and you avoid synchronous communication, you don't need to have a circuit breaker because there is no other system that you need to talk about while you handle an incoming request. So as long as you can stay away from synchronous calls, which are still allowed, but discouraged, then you wouldn't need to have a circuit breaker. That's basically the idea.
Well, so I want to talk about persistence a little bit more. What's the persistence model for one? So you have, just for listeners who are a little confused, you have in self-contained system, you have multiple self-contained systems that are communicating with each other. Each self-contained system may have its own set of microservices within that self-contained system. What about persistence? What's the persistence model for a given self-contained system in this entire company that might be running a bunch of self-contained systems?
So self-contained systems are supposed to have their own database schema. That's sort of the minimum requirement. They might even have their own database, but that's not really needed. I would argue that this is a rule that should be applied to microservices in general. So in my opinion, microservices or self-contained systems are just modules. So, you have a large system and you divide your large system into modules. And, there are these ideas about encapsulation and information hiding for modules. And usually the idea is to have an internal state and protect that state and only allow access to that state from the outside through an interface. I think that's the very core of the module concept. If you apply the module concept to an object-oriented class, for example, it basically means that you have some methods and you have instance variables, and no one outside your class should touch those instance variables. And I guess we can all agree on that. If you apply the same idea to microservices, I would argue that the state of a microservice is in the database, and the same ideas apply as for object-oriented classes. So no one should touch your state, which is the database. So you should have a separate database because it's basically your state. Encapsulation means access to the state of a microservice to the database only through the interface of the microservice or the self-contained system. So for that reason, I would argue that you should, or you must basically separate schemas, and it's very illogical not to do it because you invest all that effort into decoupling, and then you're like, okay, well, but here's my data, just use it and I don't care. And I think that's very illogical because then you have a very tight coupling on the database layer. You can extend that, so you can have each self-contained system could have its own database, a different type of database. Then you end up with polyglot persistence. However, obviously there is a downside because it's a lot more complexity. There are a lot of more of technologies that you have to deal with, and you would need to have, backup, disaster recovery for all of these databases. So I'm not sure whether you would go that far, but I would argue that if you do microservices or self-contained systems, they should all have a separate schema, possibly in the very same database.
Does this ever lead to redundant data in different systems?
Yeah, of course. And, that's sort of the downside. And I guess there are only two ways out of that. And that is either you deal with the inconsistencies and the redundant data, or you use synchronous call to a centralized service that provides the data to everyone. And then you need to deal with the problems concerning, failures and things like that. So if I get a request and I need to have some data, I can either get it from my own database, and it would probably be a replica, and you would have inconsistencies, or I would go to the centralized service and get the data from there. And then it's consistent because everyone uses that centralized service. But then you would need to deal with failure cascades and problems that might occur during that synchronous call and so on. And it's a trade-off, and you need to make the right trade-off at the right point in your system. So it's your choice as a software architect.
As we mentioned earlier, a self-contained system can contain its own microservices within it. Why would you do that?
Yeah, to be perfect, I think that's one of the things that is confusing if you talk about the idea. Because first you're like, okay, a self-contained system is an independent deployable unit, so it's a microservice. And then the next thing that you're saying is, well, but still you can have separate microservice inside a self-contained system. I believe if you look at microservices, there are different reasons why you would create a microservice. So one reason would be, here is some piece of functionality, and you want to separate it in a module, and you end up with a bounded context with a specific domain model, and you have one team that deals with that functionality, and that is basically the sort of granularity of a self-contained system. So, for example, you might have, the checkout process, and that might be such a bounded context where you have a specific model about, a shopping cart that becomes an order during the checkout and things like that. Now, it might be that one part of that checkout process, let's say the payment, it talks to an external system. And for that reason, it needs to be really scalable. And there are other requirements because that system that does the payment, that external system, is very slow and unreliable. And now you figure, well, if I separate that in a separate component by itself, that can run on more servers, or that I can tune differently with the operating system or stuff like that, that might be beneficial. So you separate that one piece of your system, of the checkout process that just talks to a payment server. And I would call that a microservice if it's a process by itself in its own Docker container and so on. But I would still be fine with that service sharing the same data model that all of the other parts of the checkout process have, because the only reason that I separated it is scalability. It's not about decoupling from the domain logic perspective. It's just because of scalability. And that is an example where a self-contained system for checkout might contain microservices for reasons such as scalability. And generally speaking, I would argue that there are these more coarse-grained microservices, self-contained systems that are around, bounded context and so on. And then there are more fine-grained microservices that are probably separated from one another for more technical reasons like scalability and what have you. So I think that is why a self-contained system might contain microservices.
Software Engineering Daily has 20,000 engineers listening Monday through Friday. If you are hiring, or if you have a product that you would like to get into the hands of engineers, send me an email, jeff@softwareengineeringdaily.com. This podcast is sustained by the advertisers, and if you would like to become one, or even if you're just curious and you want to learn more, send me an email, jeff@softwareengineeringdaily.com. Thanks for listening. Let's go back to the idea of the web interface that you advocate for every self-contained system within a company. You advocate that this web interface should be used as the point of integration between systems. Explain why that is so useful.
Because the web allows for very decoupled integration. I think that's the main point. I mean, if you look at the web, it's the largest distributed system we have, and it is based on links, and links are very decoupled because, if you have a URL, the whatever information is behind that URL, you are pretty decoupled from it. So it might be HTML, it might be, a JPEG, it might be an HTML page, including CSS and JavaScript. It might even be a complete JavaScript application and what have you. So there are little assumptions that you have on your side if you just provide a link. And for that reason, I think integrating on the UI layer is often overlooked. It is something that, in particular, backend people like myself are not, that's not what they are focusing in on, I would say. If you talk to them and say, okay, we do REST communication and that is how we integrate, it's obvious. But if you say, okay, we rather want to have some integration on the UI layer, it is not something that, comes immediately to your mind if you want to integrate systems. But it's very powerful. And that is one of the things that I like about self-contained systems, that it focuses on that kind of integration.
Can you explain more what you mean by that? Because people listening to this are probably very familiar with the idea of, okay, it's a RESTful API, I make a request to this API, and I get back a blob of JSON. And then when you're saying, oh, no, actually your integration is going to be over the web interface, some people listening to that might be like, what? What does that even mean?
One way of... So let's take a very simple example. So there is a system that allows you to do a product search. And then there is a product details service. So it provides you all the details about a product. How do you integrate those two? Well, it's very simple. The product search would just render links that go to the product details service, and that's it. And, it's a very, very simple integration. And the benefit is if the product details service decides to, display products very differently, there is no problem because all you have is that URL that you're rendering, and whatever is rendered is actually up to the product details service to decide what it looks like. So that's a very simple example of how that works and how flexible the whole approach is.
You have this set of recommendations for how to build a web interface for a self-contained system called ROCA. What are some of those principles? What is ROCA?
In it's one approach that we advocate for for web applications in general. And in a way, what it says is that you should just, create normal web applications. So it's called resource-oriented client architecture. And what you do is you would create HTML pages. The HTML pages would contain all the information. It uses REST principles, so there is a identifiable resource with a URL, and you would use all the different methods, HTTP methods, as they are intended to be used. So you would have GET requests, posts that just can be cached and that won't have any side effects, post requests that would have side effects, and so on and so on. So in a way, it is the way that we used to build web applications from the very beginning. There are some things that are a little bit harder to understand. So for example, we advocate, or Roca advocates, to use JavaScript not to contain in the business logic. And it actually says that the system should still be usable even if JavaScript is switched off. Now, of course, nowadays everyone has JavaScript switched on, so it doesn't seem to make a lot of sense at first sight. But what that really means is that all of the logic will be on the server side, and you can actually prove that it's on the server side because you can switch off JavaScript and the system still works. And that is beneficial because, for example, you cannot, for security reasons, you cannot trust the client. So the client can be tampered with, and it is also it also means that all the logic is on the server. So if you add a different interface, you can be sure, like an API, that all the logic is already on the server, and so on and so on and so on. And it's a different approach from single page apps, where you would say, basically, your client is just a very large piece of JavaScript code, and it runs inside the browser. So Roca is basically trying to go back to sort of web applications as they were meant to be, and originally meant to be, and it's different from single page app, from SPAs. And concerning self-contained systems, the advantage is that it allows you a much more flexible integration. So let's assume that you would build your system, so that e-commerce system, and you would build your e-commerce system using a single page app. So basically there is one huge single page app that would talk to a lot of backend services. That's basically how you would create it. And that's fine, but the problem with that approach is that on the one hand, if you use microservices, you are investing a lot of effort to split those backend services, but then on the front end, it's all one single page app. And that is where self-contained systems say, it's probably a smarter idea to also split the front end. And then obviously the question is, how do you do that? How can you make sure that you can compose your front end from all those small systems? And that is something that single page apps really can't do. In a way, they are just deployment monolith. And that is where the web is quite useful, because you can use links to communicate between the different parts. Or what I haven't really spoken about is transclusion. So in one of your systems, let's say in your e-commerce system, there is, a small icon that says these are all the things that are in your shopping cart. And you could transclude that from one specific system that is responsible for the shopping cart. So you would add that HTML of that shopping cart system to the HTML of all other systems. And if the shopping cart decides to change its rendering, that's fine, because, you're integrating the HTML. That's basically the idea. And there are some tools or some techniques that you can use to enable such transclusion. So you can do that on the server side, or you can do that using JavaScript and include the HTML. And it's much more flexible. So I think the synergy is, if you use a Roca-based front end, it's much easier to integrate different self-contained systems into one UI and really make a lot of use from that UI integration. So that's how it adds up. And it's not that easy if you do a single page app.
When I do shows about microservices, a lot of the conversations are around the organizational impact of the microservices architecture. Though there are benefits on the technological side, like you have this isolated context that you can scale up and down. There's other things that are advantageous technologically, but people talk about the organizational effects pretty often. What are the organizational effects of moving towards self-contained systems? How does that affect the company structure?
That's a very good question. So self-contained systems actually say that one self-contained system belongs to one team. So it actually talks about the organization, even on the definition side. And as you said...
Is it a two-pizza team?
Yeah. I mean, usually if you talk about teams, it's usually that's the size that I'm thinking about. So like, a Scrum team, it's all pretty much the same size. And for that reason, so if you look at the definition, we actually talk about the organizational impact in the definition. And I mean, if you look at it, if you do such a split as I spoke about, where each self-contained system has a bounded context, it means if there is a feature request, one team can do that in one self-contained system. So that's great, because the product owner would just talk ideally to one team, and they would just build that in one self-contained system, and they could even go live with just one release. So there is no need to coordinate concerning releases and so on, because they are isolated to one self-contained system. Features are isolated to one self-contained system. So I would argue that one of the ideas around self-contained systems is to play sort of a trick to say, okay, we are building this software architecture and it's so decoupled that you can have features implemented in one module, deployed in one module without talking to the other modules. So there is no need to build up a huge organization and to have meetings all the time to talk about when you're going to release what, because the teams are largely independent. And I think you can only do that if you really implement everything in one module. So the UI, the logic, and the persistence, because otherwise you would need to talk to other modules and to coordinate with other modules to get that feature live. So I think that's how it adds up. This is about the domain logic and the functions and the features and so on. Also on a technical level, this approach, pretty much like microservices, decouple teams from one another. So if one team says, okay, we are really going to build that using Ruby, and everyone else is using Java, they can do that because a technological decision is limited to one self-contained system, and every self-contained system, because it's a web application, can have its own technology stack. So you don't need to coordinate that much in that regard either. Now, it doesn't really mean that, you have to use every programming language on earth in every project, but still, I mean, if I decide to roll out a bug fix in a specific library, it's only my system and only my system that is being rolled out with a different version of the library. And there is no need to, coordinate a lot with all the other systems. So using this approach, self-contained system, there is independence in terms of how you implement features. And there is also independence concerning technology. And for that reason, the teams are pretty decoupled, and that's a way to, scale your organization. Let me just add one thing. Sorry. What I don't like about the discussion, sometimes it sounds as if microservices or self-contained systems only make sense if you have, a very large team. And I don't really think so. So this decoupling has a lot of benefits, not just from the organizational side, but also, you can deploy quicker. It's easier to implement continuous delivery. There are, robustness might increase, better scalability, and so on and so on. So sometimes I don't like the discussion because it really focuses a lot on the organizational impact. And sometimes I feel as if, other benefits are forgotten because the organizational impact is what people talk a lot about.
Well, the conversation that we're having might be fairly abstract for some people who are listening. We are talking about very broad architectural principles. You mentioned a company, Auto, that is an example of a company building self-contained systems. Can you talk more about that case study?
Yeah, so actually they talk about that themselves quite a lot, and there are, if you go to the self-contained systems website, you can find links where they talk about what they did. So basically they created all of their e-commerce website anew using these ideas. So they originally called it verticals because it's really, that's really what it's about. Splitting your system into verticals. And there is a blog post that says that what they call verticals are self-contained systems. Because they are the number 3 in e-commerce, even on a global scale, it's actually a very nice story because it shows what you can do using that approach and how powerful it is, and it's really core to what they are doing. So I'm pretty happy that they talk about it, they actually advocate it, and that they did these blog posts about it.
The other big trend that we haven't really talked about in this episode is the serverless movement, and I'm not talking just about Lambda, but I recently had a conversation with a guy at a conference, and he is about to launch this complex robotics platform. It's like a venture-funded company, and they were able to ship in about a year because they focused on using external services like managed machine learning from Google. They use Firebase as their database. These services are often called serverless. And then, of course, there are these things like Lambda. Are there parallels between the movement that you're advocating towards self-contained systems and the ideas of serverless? What are the synergies there? I don't know. Talk a little bit about that.
Yeah, so I think that's a very good question. I have to admit that if I look at self-contained systems, it's a more coarse-grained approach. So basically what we're saying is a self-contained system is, a web application, and, it might be a bounded context, so it might have its own data model. And I suspect that what serverless systems are really about is to have much, much smaller deployable units. And as we said before, a self-contained system might consist of, smaller microservices. So you could have a self-contained system that contains multiple microservices that run on serverless environments. But to be honest, I think that's not the focus, and it's not really what we are seeing. So I would believe, or what we see in most of our customers are more, the sort of traditional approach where you would use, Docker or some other means to deploy your self-contained systems, and not so much serverless. And I think that's probably fine. It's just, it's a rather coarse-grained approach. So for that reason, I would argue it's probably not the ideal fit for serverless.
Is there anything else that we haven't discussed about self-contained systems that you'd like to touch on?
I mean, I think one of the things that that are really challenging concerning self-contained systems and that might be worth investigating even further is that the UI integration leads to a lot of additional challenges. So one of the challenges is, so you want to create one system, so it has to have a common look and feel. So there has to be some way of creating that common look and feel. So these kinds of things, so you might have a common asset project where all the assets are in like CSS and JavaScript, or you might have a common asset server. Then you have that centralized piece of data and of assets that you need to take care of. So those are some things that you wouldn't have in traditional systems, and that are more front end type of challenges. And that is something that is interesting about self-contained systems. It's also something that a lot of people ask. So how do I get that common look and feel? How do I make sure that all of the self-contained systems really look the same? So that is, I think, something that is important and interesting. And it is something that you need to cover if you really want to start doing that, and if you really want to do it. So I think that's a very interesting and important topic.
All right, Eberhard, thank you for coming on to Software Engineering Daily to talk about self-contained systems. And I just want to say it's been a pleasure working alongside you on Software Engineering Radio for all these years. I think you were a founding member of Software Engineering Radio. Is that accurate?
Yeah, I mean, Marcus back in the days founded it, but I think I was there from pretty much the beginning. So that's actually true. I had a break in between, but I did a few of the very first shows.
Yeah, I'm very thankful for Software Engineering Radio because it's essentially the thing that I copied to build this business. So I'm glad you were a part of it and you helped sustain it long enough for me to find out about it.
Yeah, thanks a lot for Software Engineering Daily. So I really enjoyed that. Also listening to the podcast, and thanks for having me on the show.
Wonderful. Okay, well, thanks, Eberhard. Software Engineering Daily is having our first ever meetup in San Francisco, January 11th at Galvanize. If you live in the Bay Area and you listen to Software Engineering Daily, please come check it out. I would love to meet you. We're going to have some awesome speakers. We have Pete Hunt, who is one of the early members of the React.js team, who is now the CEO of Smite. Hasib Qureshi, who has been one of the most popular guests on Software Engineering Daily. Preeti Kasireddy, who has written about her career transition from venture capital to software engineering via Coding Bootcamp. Each one of these speakers is going to give an awesome talk, and I hope you can make it January 11th at Galvanize in San Francisco. You can sign up on meetup.com. You can also find the link on the Software Engineering Daily website, softwareengineeringdaily.com. I really hope to see you there.